Okay. This film is going to be a little bit tricky. This is on ionic radius. Okay? Ionic radius. Okay? Ionic radius. And what we'll do again is we're going to look at the third period, and we're going to look at the ions. Okay? Now, these are the ground rules. We have in the positive, the cations are going to be from which groups? 1 through 18. Which ones are going to be the cations? What groups of period 3? What group numbers? Could we participate, do you think? Ginny, are you back there? Are you with us, or? Yes? What groups are going to be the cations? Anybody?
14, 15, 16, 17.
No. Cations are positively charged, right? Oh. Yeah. In other words, what's going to be the charge of sodium? Not the nuclear charge. What is going to be the oxidation number?
+1.
The bonding charge. What is it? +1. Okay, so let's put them all down. Okay. Sodium is going to be +1. Well, I'll list them all for you, okay? Is that good? Is that helpful? Aluminum, silicon. What's next? Phosphorus, sulfur, chlorine. You can't put the you can't put the what? The noble gases down, they don't become ions. Okay, it's especially argon. All right, so this is going to be +2, +3, +4. Silicon is going to be a cation. Okay, so you're coming up here bothering me about tissue. Is that blood?
No.
Well, what is it?
Pink.
Okay, well, just it's over there. There's some. Don't come near go around this way. You can do it. All right, it's amazing. Okay. All right, there we go. Excellent. Well done. Excellent, Basil. Okay, now, this is going to be an anion, anion. Are we all right with that? Let's put the nuclear charges down. All right, this is going to be nuclear charge. This is going to be 11. This is going to be 12, 13, sorry. This is going to be 13, 14, 15, 16, 17. Okay, are we all right with that? Yes? Okay. Let's put also down the valence shell. All right? Let's put down the valence shell. What's going to be the valence shell? What's going to be the valence shell of sodium? Ion. Really?
1.
You think it's 3? All right. Right. What does sodium want to be just like when it bonds? What does it want to be just like? It's going to give up 1 electron. It has 11 electrons, right? Yes or no? Yes or no? Okay. It has 11 electrons, and it wants to give up 1. Which element has, if it gives up 1 electron, how many electrons will it have? 10. What element has 10 electrons?
Neon.
Neon. Excellent. What's neon's valence shell? What's neon's valence shell? You don't know. You're stunned. They're stunned.
8.
8. That's a valence shell, 8? Or is that the number of valence electrons?
10.
What's its valence energy level? What's its outer shell?
2.
What?
2.
2. How long did that take? You didn't know that it was 2? You didn't know that? What's its outer shell? Well, let's see. 1s2, 2s2, 2p6. Isn't that it? Isn't that neon? Isn't it? Okay. Here it is here. That's the nucleus. 2 electrons here. and 8 here. Isn't that neon? Isn't it? What's the valence shell? 1, 2. You only have to be able to count to 2. Wow, man. You know, like, do it. Okay? Okay, yeah. Can you do it? Okay, man. Okay, man. Okay. You get it? Okay. Zayed.
I don't think you can see that part of the board.
The bottom part.
The bottom part. Excellent. Nice assist, Zayed. Where were my videographers, though? That's what I want to know. They're asleep at a switch again. Were you asleep? You just don't care. Okay. Zayed, you going to keep an eye on things for us? Okay. So neon. What's the valence shell for neon? The second one, the outer shell. Isn't that correct? Yes or no?
Yes.
So we want to know what's the valence shell for sodium after it bonds. What's the valence shell for the sodium ion? What's the valence shell for the sodium ion? Anybody?
2.
Oh my God. Nice recovery. Redemption is yours. Excellent, Mohammed. Okay? Excellent. 2. Valence shell of 2. Yes. Now, how many electrons does magnesium have in the ground state, Alex? You weren't paying attention. That's okay. Sleep at the switch. That's not a problem. I haven't been calling on you, so you're kind of hanging out, relaxing. That's not a problem. We'll come back. I'm going to ask you aluminum, okay? Kennedy, how many electrons, total electrons, does magnesium have before it bonds? 12. Excellent. Now let's review, Alex. Why is that true? Because in the ground state, the number of protons and neutrons are the same. If it has 12 protons, it's going to have 12 electrons, right? Okay, cool. So how many electrons must it have given up to get a charge of +2? Anybody? 2. Yeah, right. Very good. Okay, good. Excellent. So, Alex, here you go. You ready? Redemption can be yours. You ready? The ion of magnesium. The ion of magnesium. What's its valence shell? As you're thinking, let me help you. Would you just hold up? Did you just hold up? Oh, you hold up 2 fingers. Excellent. All right, excellent, excellent, excellent. 2. In other words, magnesium wants to be just like the nearest noble gas called neon. Neon has 10 electrons. It gives up 2, so it had 12. Now it has 10. So it has a valence shell just like neon. So you have to go and you have to look and see what neon is. Neon is 2s2, 2p6, right? Isn't that correct?
Yes.
So it's going to have a valence shell of 2. Do you see why we do the short form electron configuration right away? Falls right off the map. Remember I also said to you, what did I say? Zayed, you're having too much fun. No more fun for you, okay? No more fun for you. Okay. Be sad. No smiling. I don't want to see teeth, okay? No more fun for you. Okay. So, you get it? So, didn't I say to you that the valence electrons are the S and Ps? Right? Didn't I say that? So right away it should fall off the page. You just have to look through the short form electron configuration and look at the P's. Yes? Look at the S and the P's. Okay. So let's move a little bit faster. What's the valence shell of aluminum?
2.
Aluminum ion. 2. Most excellent. What about silicon? 2. What about phosphorus?
Probably 2.
All right. I can see you're getting into a rut, Mohammed. All right, Mohammed, how many electrons, what's going to be the charge of phosphorus? What did we establish? That isn't it closer to argon than it is to neon?
Yes.
Remember we said that? So it's going to gain 3 electrons. If it gains 3 electrons, how many electrons does the phosphorus atom have, Mohammed?
It has 15.
Mohammed, you are a superior chemistry student. Excellent. Excellent. So if it gains 3 electrons, how many electrons would it have? 18 electrons. Now, here you go. You ready? Which atom in its ground state has 18 electrons?
Argon.
The man is on fire. We're talking the sun, okay? Scorching the earth, okay? Now, what is the valence shell of argon? Don't tell me. Let's do the short form electron configuration for argon. Is that okay? Yes? You choose the preceding noble gas, which is neon, correct? So this is argon, right? Neon. And then it's going to be what? Don't tell me. 3s2, 3p6. Isn't that correct? Yes or no, man? Let me tell you. Yes or no? I want to hear, for a yes, I want to hear, yeah! 1, 2, 3?
Yeah.
Oh, man, I'll tell you. It's Yankee Stadium in here. I'm telling you guys. Okay, so that's right. So here it is. It's going to be the third energy level. So what is going to be the valence shell of argon? It's going to be the third, right? 3, right? Yes, 3, yes, 3, yes, 3. Okay, good. So it's going to be, this is going to be 3. No secret. Don't even go there. No secret, no secret. 3, and this is going to be 3 and 3. Excellent. So let's draw the basic ring. I'm just going to draw the one ring. Is that okay? Whenever I draw the second ring, the third ring is probably going to be bigger, right? Does that make sense? Can I just draw the same size rings for the 2s and the 3s just for now? Is that okay? Is that okay? Okay, excellent. So we're going to make this 2, 2, 2, 2. And you know what? We'll use a different color as well. We'll really separate it. So this is 3, 3, 3. Is that cool? Is that coming up? Linda, are you watching? Oh, you're asleep at the switch, girl. I don't know about you. Okay, not a problem. Okay. All right. You're so good, Linda. I'll tell you. All right, is that good? Can you see that? So these actually should be the same size. They're not, but if these aren't the same size, it's the fact that your eyes aren't working correctly. These are drawn exactly perfectly the same, okay? If they're not that way, you should see a doctor and get glasses, okay? Now let's look at which set of ions are going to be smaller? The cations or the anions? The cations. Aren't they going to be smaller? Yes or no? Anybody have a cat in here? Anybody have a cat? Excellent. When you see a cat, just call it cation, okay? Last time I had a cat was with curry, okay? Anyway, now, sorry, standard joke. Okay, now, cations are smaller than anions. Excellent. Now, how many valence electrons now, the new valence shell, how many do each have? Well, how many valence electrons are here? How many valence electrons are here? Now remember, I'm going to give you, may I be your auxiliary brain and help you think? May I be? Is that okay? Yes or no? Isn't the point of this bonding thing to be just like the nearest noble gas? Isn't that the point? If I'm going to give up one electron and it's going to be like neon, how many valence electrons is it going to have? It's going to have 8, right? So, right? So aren't they all going to have the same number of electrons? So don't I have number of valence electrons? It's going to be 8, 8, 8, 8, 8, 8, 8. Isn't that correct? Yes or no? Same number, right? Are you okay with that? Linda, you okay with that? Okay, excellent. All right, we're ready to rock and roll. Here we go. Look at the nuclear charges. Look at these nuclear charges. These are for the, we're looking at the cations first. Okay? Okay? Which one is going to have the smaller radius? Sodium or silicon? What's going to be smaller?
The 8s for this one, they don't show up.
What is it?
The bottom number.
The numbers don't show on the bottom,
Is that good? Can you see that?
but the chart is cut in half.
But the title, that's okay. That's all right, as long as you can see that. Okay, we're okay? Yes, is that good? Are we there? Thank you, Linda. Very nice. Nice. I'm telling you, you are the videographer. You are a wonderful videographer, okay? Excellent. Credits by, videographer, Linda. Excellent. Okay. So, which one is going to be a smaller ring? Remember that ring thing? Is it going to be, they all have 8 on the ring. It's all ring 2. This has a nuclear charge of 11. This has a nuclear charge of 14. Which one is going to be the smaller ring? Sodium or silicon? Who says the smaller one will be sodium? Raise your hand. Okay. All right. Who says silicon? Raise your hand. Okay. Now, let me do this again. Let me go through this again. Kennedy, are you with us? Okay. Now, just think. Think intuitively. Okay? They all have the same valence. So it's all ring 2, right? So if all is even, they're all going to be the same size, right? Okay? They're all going to have the same number of electrons on the rings. Shall we draw in electrons? Shall we do that? 1, 2, 3, 4, 5, 6, 7, 8. Shall I have to do them all? No. Same number on all of them, right? Okay, now. But which one is going to have the greater pull on that ring? The silicon with a nuclear charge of 14 or sodium with a nuclear charge of 11? Silicon. Isn't silicon going to have the greater pull? So which one is going to have the smaller radius? Which one's going to have the smaller radius? Which one is going to have the smaller radius? Which one is going to have the smaller radius? Sodium or silicon? That's correct. Which one's going to have the larger radius? Sodium. Excellent. Now, let's go here. Let's go to the anions. What's the shell of all the anions? What's the valence shell? It's all 3, so they're all third, right? They all have 8 electrons, right? This is phosphorus with a nuclear charge of 15. This is chlorine with a nuclear charge of 17. Which one's going to be the larger? Which one's going to have the larger radius this time? Is it going to be chlorine or is it going to be phosphorus? Which is going to be larger? What is it? Phosphorus is going to be larger. Very good. This is going to have a greater pull. So this is going to have a greater pull. So this will be smaller. Yes or no? Are you with me? Okay, now. May I erase all of this? Okay. All right.
Do you want me to erase it for you, Mr.?
No, thank you very much. But that's okay. Okay? You're having fun. Remember, no fun for you, okay? No fun for you. I had somebody write me a note on, like they wrote an email, and they were critiquing my video. And they said something like, first of all, they called me a professor. Yeah, right. I work for a living. They said, could be good, but the teacher thinks he's too cool or something like that. The teacher's a dork or something like that. It was like, whoa, snap. Yeah. They don't realize I'm really like this. Okay. So let's organize. I want to organize from left to right. I want to organize this. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. I want to organize that from largest Largest to smallest. I want to organize it from largest to smallest. What's going to be the largest? What's going to be the largest? Total. Nope. Eamon, why'd you say that? Yeah, but what's the valence shell of sodium? I mean, sodium is going to be larger than silicon, absolutely. But what's the valence shell of sodium? 2, right? What's the valence shell of phosphorus, chlorine, and sulfur? Won't they be larger? There you go, big guy. So what's going to be the largest ion up there? Yes, excellent. Phosphorus. What's next? So, very good. Sulfur. What's next? Chlorine. What's next? Sodium. Here I am putting an S in there. Sodium. Then what? Magnesium. Aluminum. Right? Right? Matter of fact, really tiny. Silicon is like, it's like a pixel. I mean, it's really tiny compared to the others, right? All right. We're going to quit, and then I'm going to do one more over there, and then we're done. Clear? Okay? All right.